So welcome guys to this series of videos regarding developing iOS apps. We'll be for the first phase, we'll be using Swift and UIKit. Swift is the language that we will use across the course of the series. And first, let's talk about this real quick. Well, first of all, Swift is an amazing language that was released on 2014 in response of many of the problems that IGDC back then was causing in the Apple ecosystem when it comes to development purposes. So basically, they released it as a response of creating a language that is more convenient, easier to use, easier to grab for everybody, and well, grabbing stuff and ideas and practices from other great languages. They came up with this language. So this is a compiled language, so I guess many of you are aware with concepts. It's a static, completely static, strongly typed, which is great because even on web technologies, we're aiming for languages that provide us with type checkings and that level of safety when writing software. And something great about Swift is the fact that it's inferred, which means at many points we will be able to write code that is implicit, so that it just resolves many things, and out of the context where it's being typed, it can grab the circumstances of where it's standing and understand what it means without it being too verbose. So that's something fantastic about Swift that, of course, is also present in other languages, but is especially important in Swift. Something great about Swift is the fact that it's multi-paradigm. It can be worked for object-oriented programming, but also they create the concept of protocol-oriented programming. It works perfectly for functional programming, and it allows you to do things both imperatively and declaratively. So that's also amazing to find in a language, which nowadays is very important as we encounter more architectures and more ways to develop software. So let's talk about a little bit about the tool chain, which is basically the stack of tools that we'll be using in order to make all this happen. So what do we need? We need Xcode, and that's it. That's just great about developing software for Apple. Like literally just with Xcode, that will install the whole thing, the whole stack, along with Swift and the simulators and the debugger and absolutely everything. So you don't need literally anything else. Let's talk now about what can we target when using Swift. So since Swift is an open source project, basically you can target virtually anything. Like you can literally write backend applications with Swift. You can write desktop, you can write like for all the stack of Apple, and it's just fantastic just with that language how much you can achieve. Right now, maybe the only thing that you can target is web, although I wouldn't be surprised if there's already a framework out there that will transpile Swift to JavaScript and somehow let you target web for some reason. So not sure why would anyone want that, but I guess that if there's a person coming from Swift and they want to develop web applications, that wouldn't be so bad. And something super important about Xcode is the fact that right from there you can target with a single code base watchOS, iOS, iPadOS, macOS, and tvOS, which are the operating systems for each of the different devices that Apple sells. So if you just know Swift, you can target all of those and provide a comprehensive and complete ecosystem-based experience across the different devices Apple offers. And also another great thing about Xcode and the development stack for Apple is the fact that there's a framework for everything. So like almost everything you can think of that can be written as software, there's a framework that Apple designed specifically for that. So we'll go had mentioned a few of those, and the reason why I want to mention them is because they are really important, and it's very likely if you start writing apps for iOS or any of the platforms Apple offers, you will come across any of these frameworks. So the first one is called Graphics, which is a framework that allows you to handle vectors and shapes and geometry. And actually, all the UI frameworks that we'll see later actually use core graphics underneath. So literally any button, text, like anything that you can see on the screen is actually being drawn with core graphics. And core graphics lets you interact with it directly so that you can create PDFs and create any shape that you can think of. And of course, it has a steep curve, but it's still a great framework to work with if you want to achieve advanced stuff. UIKit basically is the solution that has existed for quite a long time, even before Swift existed. UIKit is a way to write user interfaces in an imperative fashion, which means literally you can write software instruction by instruction. And there is actually a mechanism called storyboards and XIBs that you can use in order to make the process of interacting and creating user interfaces with UIKit in a more convenient way. So although we can write everything from scratch, instruction by instruction, we can also do it with the storyboards. Now let's talk about Swift UI. So Swift UI is a framework that was released about 3 or 4 years ago, and this was in response to many technologies that have been emerging for writing user interfaces in a declarative way. And the reason why that's important is because we want our user interfaces to be a reflection of what certain state looks like at any moment in time. So basically, Swift UI allows us to do that, which is actually very similar to what React does or even Flutter. And actually, web development has always had a way to declaratively create user interfaces using XML-based language, which is the HTML. And of course, with even more frameworks and technologies, you can put on top of that layers that allow you to change the UI in response to certain state changes. So the UI was born in response to that, and because, of course, developers were asking for ways to create user interfaces in this fashion. So combined, I'm sure a lot of you guys are aware with this concept of asynchronous or even reactive programming. The more real and valid name is actually asynchronous. Reactive, I put there just because it's actually the word we are more familiar with. But this will allow us to interact with streams of data and subscribe to events that we may be interested in order to either run operations or even update our UI. So Combine actually plays very well with Swift UI, and Swift UI underneath leverages a lot of the Combine constructs that were actually released the same year than Swift UI was. Actually, Combine is also a first-party response to other frameworks that existed for Apple development called RX Swift, which is actually a port of RxJS and many other Rx-based frameworks, but for the Swift world. And yeah, there's other frameworks very similar to it that came prior to Combine, so like Reactive or even Reactive Swift. So Core Data is actually also a framework that has existed for quite a long time as well. And this is actually very similar to an ORM, which allows you to interact with databases in a more easy and convenient way. So you can just like literally create models and interact with those models directly without even having to write SQL instructions. So like it doesn't it gives you the tools so that you don't have to interact at a low level with your database, but still have an SQLite-based file underneath that you can use in order to provide local persistence. AV Foundation is basically the framework that Apple provided in order to let you deal with videos, audio files, and even the camera. Basically, it will allow you to port any streams of video onto any view or subview that you have on screen and play it, pause it, or even run a lot of operations on top of it. So whenever you feel like you need to write software or interact with media, AV Foundation is the solution. CoreML is actually a fairly recent framework that Apple created in order to handle machine learning capabilities. Basically, it allows you to import models within your project that you have trained prior to compile time, and will allow you to have machine learning capabilities on your app based on those models that you include on your project. ARKit is also something very recent that Apple came up with in order for allowing users to provide augmented reality experiences with the camera, of course, and actually this plays very closely with AV Foundation. So whenever you feel like you want to build a Pokemon-like app, ARKit is your technology. SyncKit is for creating 3D games and content. So whenever you feel like targeting all the Apple stack and creating a video game for those, basically you use SyncKit. And something actually that is extremely important, I left for last, but it's not because it's less important. It's actually, in my opinion, one of the most important things in software development is a framework called Exit Test that will allow you to both write and run unit tests that will allow you to keep your code consistent and reliable, and especially the most important word is predictable. So it's very important that whenever you write software, you provide unit tests and exit tests is the first-party solution that Apple created in order to allow you to do that. And more. Actually, there's more than 100 more technologies. It's really impossible to mention them all. There's quite a lot, but if you go to this page, over Apple documentation technologies, you will find all of them along with their descriptions and great tutorials that will teach you exactly how to use them. So feel free to go there if you want. And now let's dive into it, because as far as we have seen so far, Apple provides a great stack for targeting all of their platforms. They also released Swift as an open source project that will allow you to create solutions out of the Apple ecosystems with Swift. But now we will be targeting, of course, only development for Apple, which is what this course is about. We will be using, of course, Swift, and we'll be working on top of several layers in order to make our solution better and better over time. So first of all, I want to give you a moment to let you ask questions if you have any.
No? Yes, Apple VR. I do not know any device that uses that, other than, well, augmented reality stuff on an iPhone, but VR, it's still, I think it's not released yet, right?
VR is actually SyncKit, if you think about it. SyncKit will allow you to create completely virtual scenes along with environments and terrains, and basically put any kind of 3D objects that you want in there. So VR would be a solution. Now I get the idea of, okay, VR is more than that because it's just like for video games. And you want to be able to provide feedback when it comes to how you interact with any headset that you may have on. But at the same time, the thing is, Apple is not providing right now any hardware that allows you to do that kind of stuff. I mean, it is likely they will be releasing very soon something called a Reality Pro, and that's when probably they will be including the framework that is specifically enough for VR. Because right now,
Yeah.
what they're targeting is just AR, because since the devices like the iPhones or the iPads have front cameras, and even they have sensors they have something called the lidar sensor that will allow you to measure the distance between the camera and the different objects around you. They created the AR kit in response to that in order to leverage all that hardware and allow you to create experiences with AR. But right now, since they don't have the VR headset released right now, they haven't provided like something specific enough for VR right now. Yeah, but I'm sure they will once they release the so-called reality pro that it's being speculated to be released this year, actually. Did that answer your question, Roberto?
I think so. Thank you.
Okay, awesome. Any other question? No? Okay, awesome. So let's dive into it. What's our goal? Well, I'm kind of a geek, so I will be leveraging those passions of mine in order to teach you guys how to use something called the Marvel Comics API, which is actually something created by Marvel itself that will allow you to basically fetch data from the API about characters and comic books and events and many other stuff. So this app will be focused only on characters, and our features will be for the sake of looking up different characters that we may be interested in. Sometimes many people go to the movies and find out about a character that they didn't know it existed. So they can use this app to look it up and understand their background. So it will be about research, filtering, and also appearances, so that the people who uses this app get a grasp on where exactly and out what events they have shown up before. So this is it. So let's go ahead and basically we're going to create a new project. Next code, we just hit this new project, and then we have a way to target completely multi-platform apps. Right now, we'll be focusing only on iOS. This would give us a few convenient matters when it comes to using Xcode, so we target only iOS. iOS is actually targeting both iPhones and iPads, because iPad OS is actually a subset of what iOS is completely. So let's go ahead and I'm going to create this on Marvel TV. I'm gonna be using the storyboard. And actually, before I go further, I want to give you a bit of background on some layers and the reasons why you may have something so simple so far. So since this is a series, we'll be running several phases. The first technical layer will be using UIKit, using storyboards. As I mentioned before, storyboards is a user-friendly way to build user interfaces with UIKit by just like really dragging and dropping elements onto the screen. And but later on the second phase, we'll be translating that to not using storyboards and having that happen completely with code. And of course, that will allow us to provide a better concern separation using better architectures like Model View Presenter. I will give you more context on what those are. And we will stick with basic networking for now, while we go deeper to later phases where we will start leveraging combined and many other most modern mechanisms to handle networking. And then we'll start doing snapshot testing on the second phase as well. Okay, so at this time we start using storyboard, of course, not UI, because UI goes way farther in the events of our series. And let's include tests, of course. We should always include tests. So I'll go ahead and put it here. And then our project was created. So let's talk about a little bit about the structure of, I will give you a tour of Xcode so that you can understand where everything is and what this is about. So Xcode, as I mentioned before, is the IDE that we'll be using in order to making Apple development. We'll be using, of course, Swift. This is the structure of the project, all the files, including within the project. This is where we'll be able to inspect and interact with any of the properties we have selected right now. In this case, if we switch across the different files, we'll be able to target different products. So I may have to give you a little bit more context of what a product is. So whenever you write, you have a project using Swift and in Xcode, you can have several targets, and those targets will create different products. So if you have one file and it's targeting a certain product, basically that will be compiled against that product only. So that's really important to understand, because sometimes we may create a file and we are not targeting to the corresponding product. Hence, it won't compile against to the product we are interested in running. So it's very important to understand the targets. The project is something that encompasses all the targets. And of course, all the files can target as many files. All the files can target as many products as you want. These are the tests, of course, that are only targeting the tests here. And the UI test that is about functional testing, other kind of testing that we may explore later. Okay, so let's focus on the structure of the project. We have 3 separate folders. This is for the app itself, this is for the test, and this is for the functional test. We are, of course, interested when it comes to developing the application and putting all the files here and targeting the corresponding target. And of course, we are also interested in exploring the unit test layer. Okay, so let's understand a little bit of how the app works and the life cycle. As you may already know, all the apps have something called the life cycle, that are basically different events and moments in time where the application is being deployed or run or even dismissed. So depending on what state your application is in at any moment, it will be in different points in the life cycle. So the first thing that is actually run whenever an iOS app runs is this event called did finish launching with options. Right now, there's not too much, because actually everything is being handled by the storyboards. The storyboard is the tool I had mentioned to you guys before for being able to write a UI just by dragging and dropping stuff. And right now, if we go to the target and we go to this info, you will find that there's actually there's a main storyboard file base name called main, which is saying basically the application from the very beginning will be directed by this storyboard, which means the very first thing that we'll be running is whatever we put in here. Especially with this arrow, if we select this screen called view controller, and you go to the inspector here, you will see that there's actually a check mark saying is initial view controller, which means the application will start right from here. So we can go ahead and try that actually. And say, for example, application has started. And as you say, like really building user interfaces with the storyboard is extremely simple. It's just by dragging and dropping stuff. And if we target a simulator and run the application, we should be able to see exactly that. Now the simulator is booting. But in the meanwhile, you guys have any questions so far? Like, I mean, I try to understand if there's something that may have been too obvious, but it was really not obvious. So let me know, guys, if you have any questions so far.
Okay, question one. Your video is choppy, so it's probably not, it's frozen right now. So I'm very pixelated. So just in case you're not.
It's on your side, Roberto. I am able
Yeah,
to see it.
on my side, it looks good.
Then okay, then then the problem is mine. Then. Okay, second question. I come from an Android. I come from an Android background, and in that case, the application, the what you see as what you call what you see as the presentation here is just the activity rather than the application. Is the app delegate supposed to be a single window, or it's more like a single window and a single user interface? Or that also includes background tasks and all that stuff.
So by default, the storyboard is a single window, and actually we'll go across those concepts a bit more in the upcoming sessions, where we'll be handling UI kit programmatically ourselves without the storyboards. And basically, the equivalent to an activity in iOS is called a view controller, or is with UI a view. But in general, the most accurate way to compare it with an activity is really a view controller. So what you can see right now is a view controller that is actually mounted on top of a window, and that is what we are seeing right now. The application by default doesn't run any background task unless we subscribe at any point in time before the application starts running. We schedule them to run at any point, and we can start even if the application is in background. But that's actually kind of like a separate process that it starts. It's not really part of the process of the main thread where the UI is running.
Okay,
that makes sense.
So it has similar primitives.
It's very similar to Android, actually. Yeah, especially if you work with UI kit, you will find very similarities. Yeah.
Okay, thank you.
Okay, so as you guys can see, we have the app running here. We only have the application has start label here. And basically all this happened just by dragging and dropping something here onto the storyboards. So